Alright, so this stream is not going to be a live stream per se. This is just me recording the whole review session since I'm going to be busy tonight and I have a little bit of time right now. I'm going to record the entire thing so that if you want to come and view the whole thing or view certain parts, you can at any time. This is a little earlier now, so this will work out pretty good for, I think, everyone else. Alright, so first off, aside from the fact that it says questions 31 through 36, for what we're doing here, number 2 through 7, we're going to take the coordinates of our original image, A, which is at -5, 4, and apply each transformation to those points. We're going to reuse that point every single time. So if I go to -5, 4, 1, 2, 3, 4, 5, 4. So this point we're going to use for numbers 2, 3, 4, 5, 6, and 7. So first off, this notation here, little r, means reflect over the x-axis. So if we look right here, here's our x-axis. This beautiful line right there. So we're just going to simply count 1, 2, 3, 4, and then count again 1, 2, 3, 4. So that point would be our A prime. Well, that coordinate is going to be -5, -4. Alright, and then I'm going to erase this work each time just because I'm going to do a bunch of problems on this. Nice to have a clean slate. Number 3 says reflection over the y-axis followed by a reflection over the x-axis. So we're going to do 2 different reflections here. Our first one along the y-axis, which is going to be this line right here. So reflecting over that is going to put us right over here. So that is A prime. Now when I reflect it over the x-axis, then it's going to go down here, which is, I can count, right there. So that is going to be A double prime. Well, that point is going to be +5, -4. So that's what we're going to write here. Now this notation here is what's called the composition notation, where we have one notation inside of another. You guys will notice that the first thing you do is listed inside, followed by the second thing. And that's going to be very important when we read notation. We always read it inside out, from right to left. Alright, so then number 4 here, we look at this. Capital T stands for translation. So in plain English, in either notation of these, we're going to be moving our points. We're going to be sliding them. In the case here, we're going to be moving it right 3 units, because the x value tells us left or right. Positive means it's going right. The -2 means it's going down 2. So what I'm going to do, besides erase all this beautiful work, I'm going to take my point A, move it right 3 units, 1, 2, 3, and then move it down 2, 1, 2. So that point right there would be the new A prime. That's going to be -2, +2. A reflection over the y equals x line for the next one. Well, we have to be careful here because we can do this one of 2 ways. We could either draw in the y equals x line and then count, or we could use our formula, which is in your notes. I will talk about both methods. So y equals x, one way to do this is to count the diagonal spaces to the line. So right here I say that's 1, 2, 3, 4.5. There's 4.5 spaces, so I'm going to go another 4.5 spaces. 1, half, 1, 2, 3, 4. So then this coordinate here would be my new A prime. Now I can count that out, and I'm going to see that that's a +5, or sorry, a +4, -5. Another way of doing this is, if you remember in the formula tells you that for y equals x, all you do is switch the ordered pair. Since our ordered pair was starting off as negative 5, 4, the new point would now be 4, negative 5, which is exactly what we just showed. All right, now here we have a double transformation. We have two reflections going on. We have a reflection over x equals negative 3, followed by a reflection over y equals 1. So we're going to do the x equals negative 3 first. So x equals negative 3, again, you have to remember, if it says x equals, it has to go through the x-axis, so it's going up and down. So 1, 2, 3, there's my line. So I'm going to hop over there. I'm going to go 1, 2, 1, 2. So this right here is A prime. Now if I look at, oh, I did the wrong color. That's okay. So if we now then do y equals 1, then we're going to look at this line here. Again, if it says y equals, it's going through the y-axis, so it needs to go this way. So then we count 1, 2, 3, and then we count another 3. 1, 2, 3. So that right there is our A double prime. Well, that point is negative 1, negative 2. All right, the fun one. A rotation of 180 degrees about the origin. It's a little hard for me to show you the rotation technique with your paper, but if you followed the rules that I gave you for the rotation, then there is a way to kind of eyeball this. If you notice that the point A is at negative 5, 4, well, it has to do a full half turn to here. Well, in that quadrant, all I do really is swap the ordered pair, because as soon as I flip over the y and x, then that gives me the exact same coordinates. So that's actually going to give me a positive 5, negative 4. So that's going to be our A prime. All right, now looking at number 8, find the following transformations given either notation. So again, remember, pre-image is what happens before. So we do pre-algebra, which means set up a one-step equation. If you're finding the image, you're plugging in the point into your equation. So here we go. Given the translation above, describe what happens. Again, plain English. Negative 4 on the x means that we're going to move left 4. Positive 3 on the y means that we're going to go up 3. There we go. That's it. Okay. Finding the image means I'm plugging it in. So plug it into what? Well, you have the equations up here. X minus 4 and y plus 3. What do you plug in for x, Mr. T? Negative 3. And what do we plug in for 1? Positive 1. Yay! So here we go. We have negative 3 minus 4, comma, 1 plus 3. So this is going to give us negative 7, comma, 4. And that right there is my image of the point. We're finding the pre-image now. So again, pre-image means set up the equation. I can spell. So for this one, we have to be careful because what we're saying is the x minus 4 from the original transformation is being set equal to the x coordinate of our point. And likewise, we're setting up the y plus 3 equal to the 1. So those are the two equations we solve. Add 4, balance your equation out, x equals 1. Likewise over here, subtract 3. So then we get y equals -2. We do not leave our answer like this, okay? These are an ordered pair. They need to end as an ordered pair. So we're going to have 1, comma, -2. So again, finishing up, we have now an image. So again, we're plugging it in. So we're going to take 2 minus 4, comma, -6 plus 3. And then this should give us -2, -3. This one here, we're looking for the pre-image, so we're going to set up that equation. X minus 4 equals 2. Again, if you don't remember where I got that x minus 4, it comes from our original equation that's going to be given to us. That is our translation rule. And then again, the y coordinates equation is going to be y plus 3 equals -6. And so now we just solve it. Again, ordered pair, we do not leave it like that. We write it as 6, comma, -9. All right, next one. Yeah, I really need to renumber those. I don't know what happened. Okay, we're going to talk about the translation that describes these. Now, there are two ways of writing this. Remember that we have our formal translation rule, which we say t colon xy, the translation of xy maps to, and then remember you have your x plus some number plus or minus, comma, y plus or minus another number. Again, depending on whether you're moving left or right or up or down, we'll tell you that. We learned the other way too with that little kind of vector notation. We had the x comma y, little thing like that. I know that one's simpler. We could use that one, but I would like us to practice this one simply because it's a little more formal. So right here we're saying for number 9, write the translation rule for C to E. So I look at point C and I say, okay, I'm moving left 3 units, and then I move down 1 unit. So that means my translation is going to map with this rule, x minus 3, y minus 1. Left meaning negative, down also meaning negative. All right, number 10, A to B. So if I'm looking at A to B, we're moving 1, 2 units to the right, then 1, 2, 3, 4 units down. So for this one, we're going to say the translation of x comma y maps to x plus 2, y minus 4. Last one from D to A, we're moving our point 1, 2, 3, 4 to the right, and then 1, 2, 3 points up. So again, because we're moving to the right with D, we're going to be going x, well, let me write this part out. We're going to be saying x plus 4, comma, but now we're going up, so then that means that's going to be our y plus 3. All right, so now we've done all the translation rules. Now we're going to move into rotations. Now right here we have an octagon. I have not told you anywhere in the directions how many degrees are in each of these sections. Well, octagon, if you don't know what the prefix octa means that there are 8 sides. So I know that in a full circle there are 360 degrees. If I divide that by 8, I should get 45. So that means each of these angles are all 45 degrees. Again, I'm not going to do it for all of these. You should know that we can apply it to all of them. One last note, in case you've forgotten, if an angle is positive, we read this as a counterclockwise movement. So therefore, if an angle is negative, it's going to go clockwise. And I know my webcam is showing it backwards, so let me try this again. If the angle is positive, it's going counterclockwise. If the angle is negative, it's going clockwise. Yes. Okay. So here we go. Rotation about the origin of 90 degrees. We're moving point H. So point H, I'm moving at 90 degrees. The angle's positive, so I better be going counterclockwise. That means I'm moving 2 sections over 90 degrees, because each section is 45. 45 times 2 is 90. So therefore, we land on F. For letter G, we're doing a 180-degree rotation. Now, thankfully for us, it doesn't matter which direction you go, because 180 degrees just means a half turn. So starting at G, going a half turn away, we're now at point C. Now here's one, negative 45 degrees. All right, so now we're looking at letter D. We're going negative 45 degrees, which means we're going to go wrong way. Yes, we're going clockwise. So now we're going to be going right here to point E. All right, letter F, or sorry, number 15. We're going to move letter F 135 degrees. So if you're having trouble figuring out how many counts that is, well, remember that 180 is a half turn, 90 degrees is a quarter turn, and 135 is in between those two. So that means I'm going to be moving 3 little sections. So starting at F, and let's go ahead and erase this just to give us some clear space to think. If I start at letter F, and again remind myself the angle is positive, so I'm going counterclockwise. So I'm going to be moving 3 sections. We're going 1, 2, 3. So I land at point C. Now, negative 270 degrees, there are a couple of ways of looking at this. We can say, hey, I'm going 270 degrees in the opposite direction. So if I start at letter C, let me erase that. If I start at letter C, the negative angle means I'm going clockwise. So that means we're going 45, 90, 135, 180, 225, 270. Or as we like to also sometimes say, a 3/4 turn. So we land on A. Another way of doing this is if I say, hey, Mr. T, 360 degrees is a full turn. So what I could do is I could say, hey, let's take 360 and take away the 270. We're simply going to be left with 90 degrees. Well, 90 degrees right now is a positive angle. So if I start back at letter C, and instead I go 90 degrees, Would you look at that? I end up right back at A. So if you have an angle that's like maybe a little too big and you're thinking, okay, I want to try to get this to work, one technique you can do is you could say, hey, let's take away a full circle, or let's add a full circle, add a full turn to it. In this case, I had a negative 270, so I added 360 to it. Let's pretend I have a large angle, like let's say 600 degrees. I would subtract 360 from that. That would then give me the equivalent angle that's within 0 to 360. It's a little easier to work with that way. Okay, right here we have our triangle ABC. We were asked to graph A prime, B prime, C prime, which is our image, and then write the coordinates. All right. So right here I'm looking at this and it says a reflection over the y-axis. Well, here's my y-axis. This is my mirror. So point A is going to move from the left side to the right side. It's going to flip over. How many spaces? 1, 2. 1, 2. So it's going to end up in that little spot right there. Likewise, B is starting on the right side, and it's now going to move to the left side. So 1, 2, 1, 2, right there. Last but not least, we have point C, 1, 2, 3, 1, 2, 3. A, B, C. Easy as 1, 2, 3. And there we go. All we have to do now is write those coordinates. And part of that just kind of involves us counting. So we have a positive 2, positive 1, negative 2, positive 3, and lastly we have negative 3, negative 3. Not too bad. Again, we have to make sure we really understand which axis goes where, and then if we have other lines like y equals, x equals, and then, you know, y equals x, y equals negative x, we're fully aware of those. Let's jump to 18 now. Ooh, look at that. A reflection over the y equals 1 line. Well, y equals, it has to go through the y-axis. Got to go this way. So let me make the highlighter a little more narrow since I wanted to go here. Y equals 1. Perfect. Now, something to note, if the line of reflection goes through a point, that point stays on itself when the reflection occurs. So in other words, A is going to land on itself and become A prime. Yay. Letter B is going to reflect over 1, 2, 1, 2. So we're going to place the point right there. And likewise, C is going to reflect upwards. 1, 2, 3, 4. 1, 2, 3, 4. Uh-oh, almost messed that up. There we go. So again, make sure you label your points. Part of what I'm going to be grading you on is proper notation. So after you've connected your triangle, we got to label them. This right here is C prime, B prime, and A prime. So again, list the coordinates. We're going to just write out each ordered pair. So that's going to be negative 2, comma 1. Let's see here. B is going to be positive 2, negative 1. And C is going to be at 3, comma 5. 1, 2, 3, 4, 5. Yep. And again, if there are any mistakes I made, just go ahead and, you know, kind of let me know, and I'll try to fix them for next year, but I think we're looking okay so far. 19, we're doing a glide reflection. So the glide reflection, again, we have to make sure we follow the order first. You're going to glide, then reflect. And again, if you don't remember, a glide is just a translation, but only in one direction. It's either going to go left and right, or it's going to go up and down. It's not going to go up and left. It's not going to go any other combination of that. All right, so here we go. I already gave you the triangle, so we're going to glide it. When I look at this, I see, oh, x minus 3. I'm moving all of my points left 3. So let's go ahead and do that on the graph. 1, 2, 3, 1, 2, 3, 1, 2, 3. So there's my B, there's my C, and to be correct, B prime, C prime, and A prime. So before I get too far ahead of myself, let's write these coordinates in. So that's going to be -3, +3. That is -1, -1. And then lastly, C is 0, 2. Okay, the second part of this we have to look out for is this reflection over the x-axis. So I go over here and I say, here's my x-axis. This is my mirror. All right, now let's flip stuff. So let's use green. So I'm going to go 1, 2, 3, 1, 2, 3, and then get rid of that. 1, 1, and while I'm at it, 1, 2, 1, 2. And then again, oh geez, I might have messed that up. Yep, I did. That's okay, I'll fix it. And then again, make sure the proper notation, that is B double prime, A double prime, C double prime. All right, so there's our glide reflection. Let's go ahead and label those coordinates. So A double prime is now going to be at -3, -3, -1, +1, and 0, -2. All right, we got a couple more. Got number 20, and then we got our constructions, which obviously I won't be able to do on this video, but for the construction portion, I'll review it at the beginning of class. We probably have about 15 minutes, maybe 20 minutes to go over some of these questions, but I want to primarily focus on the compass work, make sure you guys know exactly what you're doing. All right, last one here, gliding. Well, now this time it says y minus 2. So that means I'm not moving left or right, but instead I'm now going to move up and down. Specifically, I'm moving down 2. So take all of our beautiful points here, and let's move them down 2 units. 1, 2, 3. C prime, B prime, A prime. Okay, so now again, don't get sloppy. Write in your coordinates. So that's going to be, ooh, can I count? Yes, 0, 1, 2, -3, and lastly 3, 0. Now we're going to reflect, and right here we have it as x equals -1. Yes. So again, I'm thinking to myself, x equals, it's got to go through the x-axis, so that's going to be up and down. X equals -1. So let's go ahead and now reflect all of those points across the opposite side. So that means A prime moves there to A double prime. C prime, 1, 2, 3, 4, 1, 2, 3, 4, moves right over here. And then lastly, B prime, 1, 2, 3, 1, 2, 3. And again, please, 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 on your test, please make sure that you actually label your points, connect your dots for your triangles, because if it ain't pretty and I can't read it, it's not going to go well for anyone. Okay, write your coordinates down. 1, 2, so that's -2, 1. This is, let's see here, 1, 2, 3, 4. So -4, -3. And then lastly, C is at -5, 0. Okay. So now we have done the entire review. This is not all that's on your test, right? You guys need to know conceptually what's going on. You need to understand all these different things. What is a transformation? What are examples? A rigid motion. We've talked about 3 examples of rigid motion. Okay, so you need to know what those 3 are. Give you a hint, they're all the transformations we've done. Okay, and then you need to be able to give examples and show me the notation. Again, that is what's on your worksheets, the ones where we had our capital R or our lowercase r. And then you had the extra parts. At this point, there isn't anything else that I have for you. Again, don't hesitate to email me and ask me questions or even use the Remind app. I can't promise I'll be able to answer them right away, but I'll do the best that I can. And just kind of slow down the video if you need to go through each of the parts and see, you know, what you need to work on, what you need to remember. This section, or sorry, this unit is not as long as our first unit, so it shouldn't be as much, but that doesn't mean you should, you know, slow down on your studies. Make sure you really understand each of these transformations. All right. I hope you guys have a wonderful night studying. Again, I look forward to helping you guys tomorrow morning during tutorial, brunch, and lunch, and we'll work on the construction stuff before you take your test. Take care. Bye-bye.